I'm Delon Kamak. Today we'll be reviewing Linux operating system. Before getting into Linux, we have to understand what an operating system is first. An operating system is a fundamental piece of software that manages communication between the hardware and software in a computer system. The API or application program interface allows the application to make service requests through the OS to run the program. In other words, programs, whenever they are executed, the application program interface sends requests to the OS in order for these programs to run properly. The OS user can interact with the system through the graphical user interface also, or through the command line. You can use this to perform tasks like apt-get or other things to look for information or anything like that you might need. Moving into Linux. Linux is actually an open source operating system capable of running various software applications and programs. Many of them are open source, much like Linux itself. It has a open source code, leaving Linux to be a free operating system. Can be used from anything from smartphones to cars, supercomputers, home appliances. It's pretty much everywhere. Support and system security make the OS a great choice for many companies because it has a lot less of a chance of viruses or malware like that, like Windows is. Linux is much more safer. Linux has many interactive components, much like the bootloader. This software loaded by the BIOS. Once it is turned on, the bootloader's job is to load the operating system and kernel and its other needed components in order for it to be used later. The bash shell, the command line interface, used directly to execute any commands for the system, much like what I was talking about before. There's also the display monitor, which is the home screen. This is basically your sign-in screen before you actually make it to your home page. There's also the desktop environment, which is basically like your home screen that everybody's used to, much like Windows also, where you've got all your folders and files placed so you can easily get to them. There's also the control panel, which is actually also another open source application that you can download and use. There's many different kinds. This basically allows the user to access any settings or information that a system administrator may need. Alright, moving into the Linux architecture, which actually contains two distinct levels, one the user space and the kernel space. The user space executes user applications and also contains the GNU-C library. This library allows the system to transition between the kernel and the user space application. Kernel space is the second level, which can be further divided into three sublevels. These sublevels contain the architecture independent code and the architecture dependent code, or the board support package, as well as the control and read-write functions. There are three major components of Linux, much similar to what I said before: the kernel, the system library, and system utility. The kernel interacts with the hardware of the system to run all major applications and processes, similar to what I said previously. The system library are specific functions that decide which programs or applications actually interact with the kernel. And then the system utility programs perform the special tasks that are managed through the individual levels within the system. Linux kernel subsystems, there are 7 different subsystems. There's the system call interface, process management, virtual file system, memory management, network stack, architecture dependent code, and the device drivers. System call interface and process management. The system call interface is what provides the functions necessary for the system to perform system calls to the kernel from the user space. You can find this SCI implementation using your commands in the command line. Process management is responsible for the execution or processes of threads. Also in process management, the need to share the CPU between active threads. The kernel implements a novel scheduling algorithm that operates in constant time, regardless of the number of threads vying for the CPU. Pretty much meaning you can have more than one thread or more than one process, more processes running than you do nodes, or what was it called? Basically, you can have multiple threads and processes running at the same time, and it switches back and forth between these threads to keep it running efficiently and smoothly. Virtual file system is a layer that is above the file system and gives the user access to different file systems. This optimizes access to physical devices. This keeps data around for a short period of time, basically like short-term memory, in order so that it can be retrieved later if necessary. And then at the bottom is the drivers, which interface with the actual physical drivers or devices. Memory management. Linux uses hardware to manage virtual memory, and this virtual memory is then broken down into 4 kilobyte pages. Pages contain 2 different parts, the offset and the virtual page frame number. When a process executes a program, it reads the instructions from the virtual memory and then executes it from there. Page tables. The virtual page frame number is pulled when a virtual address encounters a processor and then changes it into a physical page number. And then the offsets are used to aid the processor to find the exact address needed. The page table contains 3 different pieces of information when looking at it. There's going to be a flag that describes whether the entry is valid or not, the physical page frame number as described by this entry, and access information regarding the page, like read only, write only, etc. The network stack actually contains 7 different layers. This is what allows the application to be able to access a network through a physical networking device. These 3 layers make up these 7 layers make up 3 different sets. These are called the user space, the kernel space, and the physical space. Both the application layer and physical hardware layers are all both individual, leaving the 5 in between from system call interface to the device drivers, all residing within the kernel space. The architecture dependent code in the device drivers. The architecture contains specific subdirectories that are important for efficient system operation. Each architecture subdirectory contains a number of other subdirectories that focus on a particular aspect of the kernel. These are boot, memory management, other types. The device driver is also responsible for holding most of the source code that allow the user to access certain hardware devices. In other words, without this code and access to this code, these devices will not be accessible or usable. Multitasking and process scheduling. Multitasking in Linux usually is a process called time slicing. This allows the system cores to run more processes by switching between multiple processes on each core. It's much like I was explaining earlier. If you have a specific number of cores, usually there would be one process per core, but this allows you to run multiple processes for each core while that core switches back and forth between those processes. And this is done by the process scheduler. To make this more efficient, each process has a level of importance that the process scheduler uses to assign priorities or nice values to each individual process. These nice values, they range usually from -20 to 19 to determine the importance. By default, processes will inherit their nice level from their parent. This is usually 0. The higher the nice level, the less the importance for that process, meaning that a higher level, or a lower level actually, nice value will be processed first. Only privileged users are allowed to modify nice levels or raise to lower them, and the price levels can also process levels can also be displayed through the process command using the command line. Linux security features. Linux implements user accounts with only one root account, meaning that only one account has access to all administrative tasks on the system. Accounts can also be put into groups, and within this group, any member within this group will have access to any and all information that is necessary. The read, write, and execute are tasks allowed depending on the file permissions. So you may have some permissions based on your account that will either let you read, write, or maybe just write and execute, or maybe just read. It just depends on the file permissions based on your account. And sensitive and private data can also be encrypted with passwords to secure the files and make sure that no one accesses that file that you don't want. Let's see, the OpenSSH also allows for remote access through encryption to modify, view files and software if you are away from your system, basically, much like if you get a virus on your computer or you have some kind of issue, you can access it from a remote location or have someone access it from a remote location in order to fix the problem or figure out whatever it is that they need to figure out. Host integrity testing. This ensures that the computer does not become corrupt or compromised by any viruses or malware or any corrupt data within the system. These can all be tested through previous versions of these files that were saved before. All of these can easily be, all program files that were included in the original software that's included with your distribution can all be easily restored using the software management tool. And this also contains a backup of all files saved in a previous backup file that have been saved. System support. Linux uses directories organized into tree-like file systems and sorted into 3 different types of files. These are much like regular folders that you would see using Windows. They're basically the equivalent. Ordinary files, these are text or program instructions or data files. Directories, as I said, have the same purpose as a folder and stores both normal and special files within them. And these special files, these are shortcuts of files that provide access to certain hardware used by the system. So without these special files, access to certain pieces of hardware will not be allowed. And you can also search and list all files and directories within the system, including hidden files, by using the command line. OS updates. Updating Linux is actually pretty easy. There are 2 pretty simple ways to take care of this. The first is using the graphic user interface. You can use that to open the software updater, and then from the software updater, select the install that you, the install available, and the installer should handle the rest. The second technique is to use the command line. There's quite a few more steps, but it's also very easy. The first thing to do is to go to the command line and type Control-Alt-T, and type, well, first you're going to hit Control-Alt-T, and then from there you're going to type apt-get update. And then from there you'll have to input your root password to be able to access this. From there you're going to install the after that you will install upgrades also by typing apt-get upgrades in the command line, and which you will also have to re-input your password. From there you will be prompted to confirm that you want to upgrade. You can just do this by pressing yes, or the enter, or pressing Y and the enter key. The same goes for no if you don't wish to. Then the system will take some time to download. This could be anywhere from a couple seconds to a couple minutes depending on the update and network connection as well. In comparison to other operating systems, it's very cost effective. Windows is free, like I said before, compared to other operating systems, which can run anywhere from $75 to $170. So Linux is actually completely free, including the open source software that you wish to use. Of course, there are applications that may cost depending on what it is, but it's very cost effective. It's got the personalization panel, which allows you to do much more customization and modifying of the actual system, so that you can have it set up basically the way that you want. Whereas other operating systems kind of have a set format. You may be able to change background pictures, or setting certain file settings, things of that nature, but overall Linux has much more of a capability of modification and personalization. It also uses multiple types of architectures and device managers. Like I said before, there are multiple different ones that you can download and use depending on what your preference is, so you're not as limited as you may be with another operating system. like I said, it also has free commercial support available to companies like Red Hat or Linux Care that provide other open source applications as well. Um, Even though Windows is really kept in mind as the basis for most operating systems, Linux itself also has software applications that allow you to run similar programs or Windows programs within the system itself also. But it is much more limited to the applications available because of the fact that most applications are mainly Windows compatible. Along with Windows or a few other operating systems, it is capable of running on a dual boot system. And it will also allow the user to develop, test, and implement software within the system. So, and this actually does it without installing it to the system first. So you can test an application or program or even a certain type of software. And if it does not work the way you want it to, or you do not like the way it looks, then you can easily pull it back off and use another one. And then, unlike most other operating systems, if you have a copy of Linux, you can use it on multiple systems at one time. And so, in other words, if you have 3 or 4 computers in your house, you can use that copy of Linux on all 4 of those computers, whereas most other operating systems are also very limited. And that's it for today. Thank you.